Have you ever stared at a massive, undocumented batch script or a sprawling calculator class and wondered how it got so bad? When logic dictates thousands of transactions, it usually devolves into tangled procedural code. When faced with calculating daily interest or tracking complex loan fees, it is tempting to assume your company's business rules are entirely unique. Developers often start from a blank slate, inventing bespoke logic for every new feature. But accounting and inventory systems have existed for centuries. Software engineers have cataloged the most common business modeling problems into what are called analysis patterns. These are reusable groups of domain concepts, entirely distinct from technical infrastructure patterns, like the Gang of Four's singleton or factory. Studying these patterns gives you an immediate, road-tested vocabulary. Before you write a single line of code, you can sit down with a business expert and bring up edge cases that usually take months of painful iterations to discover. You are not looking for a pre-packaged solution to drop into your codebase. You are borrowing the distilled experience of other developers to skip the initial, expensive phases of trial and error modeling. Let's see this in action by refactoring a cumbersome loan application using Martin Fowler's basic accounting pattern. Instead of overwriting a single balance field in a database, the pattern introduces an account object that calculates its balance from a long history of discrete entry objects. In a textbook double-entry accounting model, every credit requires a matching debit. If a customer is charged a fee, an interest entry is made, and it remains tightly linked to the specific payment entry that eventually clears it. But when developers present this rigid transaction model to actual financial domain experts, it creates friction. The experts will quickly point out that in day-to-day operations, earning interest and receiving a payment are treated as entirely separate accounting events. The textbook pattern got the relationship wrong, but the conversation it sparked was exactly what the team needed. It introduced a precise term into the team's ubiquitous language, the accrual, the act of accounting for income at the time it is earned, regardless of when the cash actually arrives. This UML diagram shows the resulting architecture. Discarding the rigid link between accruals and payments, developers dismantled the bloated interest calculator at the top. In its place at the bottom, they built distinct focused accrual schedule and income accrual classes. The textbook pattern failed to fit the exact requirements. Yet it succeeded in its primary job, provoking the right conversation with the right people to uncover a critical, hidden business concept. This exact same approach works for untangling the dreaded nightly batch script. Often, these scripts operate as a black box, where massive amounts of critical business logic are hidden away from the rest of the system. We contain this by introducing the posting rule pattern. The concept is straightforward. An entry placed into one account automatically triggers a mathematically derived entry in a second account. The complexity lies in when that second entry actually happens. The pattern offers 3 specific execution strategies: eager firing, where the new entry is spawned instantly; account-based firing, where the initial account stores the request for later; and posting rule-based firing, which executes based on an external clock. By assigning clear, explicit names to these 3 timing strategies, developers can cleanly separate the when from the what. The execution timing is completely isolated from the business rules calculating the amounts. As a result, the massive procedural script shrinks. It becomes a thin, elegant coordinator whose only job is to fire off schedules, while the actual rules governing your business live safely inside the domain layer. Integrating these patterns requires a strict discipline. You study the textbook concept, compare it relentlessly against your specific domain, debate the differences with your experts, and mutate the design until it matches reality. Never treat an analysis pattern as a copy-paste code template. Do not force your actual business operations to bend just so they fit neatly into a comfortable theoretical model. If your domain experts do not use the vocabulary provided by the pattern, discard those terms entirely. Your code must speak their language, and pay close attention to downstream implementation consequences. An elegant object hierarchy on a whiteboard can easily turn into a sprawling nightmare when mapped to relational SQL tables. Leverage accumulated industry knowledge to get a massive head start on complex problems, but never surrender your own judgment to a textbook. Keep your architectural boundaries strict, build deep models, and adapt the pattern to the reality of your domain.